Hello AP Physics 1, it's Mr. Ng, and I got a tricky one for you. It's number 29 out of your current homework set. So here, by the way, I love this picture of this woman pulling herself up by a basket. But basically, a window washer pulls herself up using the bucket pulley apparatus shown here. How hard must she pull down to raise herself slowly at constant speed? And of course, at constant speed, we know that there is no acceleration. Okay, so the trick to this problem, and I bet you did it and you're like, I'm not getting the same answer. And let me show you how you might do it wrong. You might draw a free body diagram that looks like this with mg and then ft. And only one ft up because you're only thinking about this rope, right? And then in this case, when there's no acceleration, mg should equal to ft. But that is not the case here. Instead, look, she is also connected to the rope. So really, get out of here. We have this bucket woman system. This is mg, obviously. And then we have the tension that's moving up, ft. But really, we have a little pulley, and the tension actually happens here too. Look, this rope is also pulling on the woman. But you're like, no, Mr. Ng, she's pulling down on it. I know she's pulling down on it, but there's also tension of the rope pulling on her. It's not like the rope is pushing down on her, right? That's not happening. The rope is also pulling down up on her. So FT happens twice. That's the trick to this problem. FT happens twice in this problem. So let's look at part A. Part A says, how hard must she pull down to raise herself slowly at a constant speed? And we already know that means there's no m times a. So we know that F net, good old Newton's second law, is equal to 2ft, right? She's moving upwards, so we're going to start with 2ft, minus mg, they're in two different directions, is equal to m times a. We know there's no freaking m times a. It's going to be 0. It's constant speed. So that means, oh, I don't need you here. That means 2ft minus mg is equal to 0. So 2ft is equal to mg. Ft, the tension, right, meaning how hard she needs to pull, is equal to mg divided by 2, which is equal to, let's see, how heavy is she? 65 kilograms times 9.8 meters per second divided by 2. And I got, oh, let me see, I got 318.5 newtons. How many sig figs do we need to do? 15, 65. I got to put it to 2 sig figs, so 320 newtons. That's part A, right? I know it seems tricky, but this is how pulleys work. If both ropes on the pulley are connected to the same system, they reduce the amount of force needed. That's just how pulleys work, okay? Let's do part B. Meaning she doesn't have to be super swole to pull herself up, right? That makes a lot of sense. Part B is asking if she increases this force by 15%, what will her acceleration be? Okay, so now we have an actual acceleration. Let's use that equation that we already did. F net is equal to 2ft minus mg is equal to m times a. And now we know that she's going to be moving because she's increasing the force a little bit. So we need to start kind of plugging in. We know that ft is no longer ft, right? We know that ft is now 1.15 ft. So 2 times 1.15 ft, right? It's a little bit, 15% more is 1.15, right? Minus mg is equal to m times a. And just to kind of prep you for the test, I did it in a way where I got it all the way down to a. Many of you are going to be really tempted to just plug in now. If you have to plug in now, go ahead, but it'll help you if you do how I do it. So I want to get a by itself, so I'm going to divide both sides by m. So these m's cancel, this m does not. So that means let's see, 2.3 ft divided by m minus g is equal to a, right? The m goes on both sides, right? I mean, you can't just get rid of this m once, right? It's still 2.3 divided by m, right? So if I finally plug in, I know that ft was right here, 320, so 2.3 times 320 newtons divided by the mass again, which is 65 kilograms minus 9.8 meters per second squared is equal to A. And if you plug that all in, A is equal to 1.5 meters per second squared. Okay? So meaning if she increases her force by around 15%, that means she's going to start accelerating, right, moving a little bit faster by 1.5 meters per second. Kind of makes sense. Again, biggest trick is knowing that the pulley, both sides of the pulley are connected to her, so it has two FTs pulling up. Thank you very much for watching, and I greatly appreciate how much work you're putting into this class. I know sometimes it gets confusing. Don't stop asking me those questions. I want to help you as much as I can. Have a good day. Bye-bye.